This is part 2 of lesson 7.6. We're talking about similarity transformations, specifically dilations, when we're enlarging or reducing a shape. So, verify similarity. You can verify that a dilation produces a similar figure by comparing all corresponding sides and angles. For triangles, you can also use SAS similarity. There's other things you can use for triangles too. Remember SS similarity? There was SSS, all three sides similarity, AA similarity. There was another one as well. I don't think we're using the other one for this one. But for this lesson, it's asking you if a shape is similar. So we can see that it's been enlarged or see that it's been reduced, but we want to know, was it made bigger? Or sorry, we want to know if it's still similar. Was it enlarged or reduced by the same ratio on all sides of the shape? Okay, so example, graph the original figure and the dilated image, then verify the dilation is a similarity transformation. So here it gives us all the points. We have to graph all the points, right? So once we do, it looks something like this. And then we can compare all the corresponding sides. So I'm going to highlight them in different colors. This top is corresponding to this top. We have a angle here that's congruent. It's a 90-degree angle, which is what we need in SAS similarity. Two sides and the angle between them has to be the same. This long side corresponds to this guy. And then, of course, since it's a right triangle, the hypotenuse corresponds to the hypotenuse. So we want to know if this is still, if these are two similar shapes, right? If they all have the same ratio on corresponding sides. So this one's super easy. We can look at the pink and the orange sides until they are. Then we have to use the distance formula on that third side. So AB, 1, 2, 3, 4, 5 units, right? This is 1, 2, 3 units. So this is the new, this is the original, this is the pre-image, this is the image. So we're going to do 3 over, what did I say this was? 5. Right, this is the pink. That's our scale factor. So if it's that way for the orange and that way for the yellow, then we're good to go, right? So now we're going to look at the orange. And I'm going to do new over original. So 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. Is that the same? 1, 2, 3, 4. Oh, that was 2.5. Sorry, my fault. This one was 2.5. 2.5 over 5. This is 4 over 8. Well, we know 2.5 over 5 is the same thing as 1/2, right? I shouldn't have written that there. Sorry, let me grab this guy right here. If we look at 2.5 over 5, that was my fault. I eyeballed it wrong. And we want to get rid of this decimal. I'm going to multiply the top and the bottom both by 10, right? This by 10, and do the same thing on the bottom. So 2.5 times 10 becomes 25. 5 times 10 becomes 50. And then I can divide the top and the bottom by 25, actually, and I get 1 over 2. So 2.5 over 5 is the same thing as 1/2. 2.5 over 5 equals 1/2. 4 over 8 equals 1/2. So far, so good. And now we have to compare the yellow sides, right? And in order to do that, I have to find the length of both of those. So I would use the distance formula. And I don't have, yeah, I do, a blank sheet of paper. Totally have it right here. Haha. All right, so for side BC, those 2 points of side BC are, this guy is over 2 up 4. And this guy down here is backwards 3, down 4. So I can find the distance between those sides, right? Distance equals square root of x minus x squared, 2 minus -3 squared, plus y minus y, 4 minus -4 squared. These become plus signs, double negatives. 2 plus 3 is 5. 5 squared is 25. 4 plus 4 is 8. 8 squared is 64. And 25 and 64 is 89. All right, square root of 89. All right, so that's the length of the long guy. Now I want to compare that to the length of EF. So the endpoints for E and F are over 1, 2, 3.5, comma, up 0, and over 1, down 4. Okay, so I'm going to find the distance. Square root of 3.5 minus 1 squared, 0 minus -4 squared, becomes 0 plus 4. 2.5 times 2.5 is something 0.25. What am I doing? 6.2. 2.5 times 2.5 is 6.25 plus 0.4 times, not 0.4, sorry, 4 squared is 16. So this becomes 22.25 and 89. And so we're going to write smaller over bigger. That is square root of 2225 over square root of 89. And what can I do here? If I multiply that by 4, I'm trying to figure out how I can get rid of this. So the whole thing is 22.25 over 89 under one big radical. And then I multiply it by 4. Oh, if I multiply it by 4, I get 89. And if I multiply 89 times 4, I get 356, which tells me this is 1/4, all under the radical. And then I can separate my radical into the top and the bottom. Square root of 1 is 1, square root of 4 is 2, so this is equal to 1/2, which is the same as all the others, right? Square root of 22.25 over 89 equals 1/2. So since they've all been dilated by the same amount, yes, this is a similarity transformation. Oh, you know what? I'm using side, 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 and they said to use SAS, my fault. Well, we could have stopped there. We could have done the pink and the orange, We saw they were both 1/2, same ratio, and they were separated or joined by a congruent angle. So similar sides joined by a congruent angle meets the SAS similarity rule. Sorry, I wasn't paying attention. I got carried away. You could also show that all 3 sides are similar, right? And that would be the SSS similarity rule, which I believe we're going to use on this other shape. Okay? Hopefully that makes sense. Read the directions, please. Do as I say, not as I do, I guess. All right, original, we have these guys. Image, this is a pre-image. Original means pre-image. Okay, so if I graph both of these, the original is this darker one. The new guy is this lighter one. So clearly we shrunk it in some, but we need to make sure that we did so proportionally so that it's a similar transformation. Use distance formula to find the length of each side. Well, luckily for you, they already have it done all down here, so we don't have to worry about it. I'm going to compare side GH to side LM. So here's GH, here's LM. They are not the same. Oh, they don't have to be the same. Just kidding. Never mind. GH and LM, so their ratio would be original on bottom, new on top, new over original, 2.5 over 5. Which, as we said before, if we multiply by 10, is 25 over 50, or 1/2. Okay, so that's the orange. Let's do pink. HJ, which is this side, compare it to NM. HJ is 5, and M is 2.5. It's the same ratio, so it should be exactly the same. 2.5 over 5 is 1/2. So far, they've got the same ratios, right? And then the last one here is this bottom guy. And 1 is 8, and 1 is 4. And 4 over 8 equals 1/2. How did I know to do 4 over 8? It's this ln over gj. ln is 4, gj is 8, 4 over 8 is 1/2. So since they all have the same ratio, all the corresponding sides, then yes, this is a similarity because of the SSS rule. And it says so right down here. This is what I did for this one, and I should not have. I should have stopped right here and not done that extra work, but same difference. All right, so let's do a couple down here. I actually went ahead and kind of drew them out. So for this first one, it gives us the original and the image, the original and the new. The image is the new, the original is the pre-image, right? So we can go ahead and sketch it to see what it looks like on here. So for the original, -4, -3, that's point A. 2, 5 over 2 up 5, that's B. And C is over 2 down 1, 2, 3. So it's a right triangle. And then for the second one, the new image, -2, -2, that's point D. E is over 1 up 3, and F is over 1 down 2. Well, it certainly looks similar, right? But we have to make sure that it is. So I want to start comparing sides, right? Now I know since this is a right triangle, I can figure out if they're similar by the side angle side similarity, which means I only need to compare this side to this side and the bottom to the bottom. I don't have to use the distance formula on that third side because they're both 90-degree angles, so I could use side, angle, side, and side, angle, side similarity. Okay, so that's going to make it easier. All right, so this is 1, 2, 3, 4, 5, 6, 7, 8 units. And this is 1, 2, 3, 4, 5 units. And the original was the big guy and the new is the little guy, so it's going to be 5 over 8. That's for the pink side. So we just need to make sure that the orange is also 5 over 8, right? Same thing. So the smaller is 1, 2, 3. And the larger, 1, 2, 3, 4, 5, 6. All right, they don't look like they're the same, right? 3 over 6 is 1/2. 5 over 8 is not 1/2. But let's go ahead and cross multiply to check and see. 3 times 8 is 24. 5 times 6 is 30. So those are not the same, right? They're not similar. For this to be similar, it has to fit the side angle side similarity rule, and these do not fit that. So no, graph the figure in its image, we did. Verify that it's a similarity transformation, not similar. Can't take for granted that they're all going to be similar, because they're not. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 5 over 8 is not the same as 3 over 6. Interesting. Looked like it would have been. All right, and then let's do the other one here. Drew that one out as well. So I did pre-image over image. It's original over new, right? So let's go ahead and graph those. P is -4, 1. Q, -2, 4. And R, 0, 1. All right, and then the new image, W over 1 down 1.5. X is over 2 down 0. And Y is over 3 down 1.5. So it's this little teeny tiny guy. So So it looks like it was a reduction, but we just need to see that they're similar, right? So for this, we don't know the angles, so we actually do have to find the length of all three sides. So we're going to compare the orange and the pink. Sometimes these lessons are like painful because not that they're super hard, but it's a lot of tedious work. And you haven't really had one of these in a while where we have to do all these distance formulas. I mean, you know, for this one it is going to be. The next one's not as bad, but this lesson, yes, you're going to have to do distance a lot. Okay, so now we're going to compare the two, and we have to set up a ratio, and we always want to do the new over the original. So let me grab a sheet of paper. I'm going to use my blank paper for this. All right, so we want to compare PQ and XW. PQ and XW. Or WX or whatever. Okay, so the coordinates for P and Q are -4, 1 and -2, 4. And XW is 2, 0, and 1, -1.5. All right, and we want to use distance formula to find the length of each of those, right? So the distance of PQ, square root of x minus x squared plus, and I did -4 minus -2, so it became a plus. And then 1 minus 4. -4 plus 2 is -2. -2 squared is 4. 1 minus 4 is -3. -3 squared is 9. That becomes square root of 13. And then for XW, square root of 2 minus 1 squared plus 0 minus -1.5 squared. 1 squared is 1. 1.5 squared is going to be something 0.25. 2.25. And then I added 1, so that is square root of 3.25. Okay, and it's the new over the original. Let me just push this over here. This is the original, this is the new, so it's the smaller over the bigger. So square root of 3.25 over square root of 13. And I want to multiply it by 100 on the top and the bottom. I'm going to separate this. 3.25 over 13. I'm going to multiply this side by 100, so it becomes 325. Multiply the bottom, 1300. And now I can, I don't know, I'm sure there's a much faster way to, you know what? Yeah, I'm not going to do that by 100. Just kidding. I'm going to multiply it by 4. Because all I want to do is get rid of the decimals. And 0.25 times 4 is 1. So 12, that becomes 13. And 13 times 4 is 52. And then I can divide the top and the bottom by 13, and I get 1 over 4. Then I can separate the top and the bottom, the radical signs. Square root of 1 is 1. Square root of 4 is 2. So that's 1/2. Okay, so I know the scale factor is 1/2 for that guy. Okay, next we have to find the length of the yellow sides, QR and XY. So using distance formula, QR, distance of -2 minus 0 squared plus 4 minus 1 squared, and XY is the other. So if I set that up, 2 minus 3 squared plus 0 minus 1.5 squared. Okay, so then if I simplify that, 2 minus 0, -2 minus 0 is -2. -2 squared is 4. That's 3. 3 squared is 9. Square root, which is square root of 13. If these are the same, I know it's going to be the same ratio. 2 minus 3 is 1. 1.5 squared. And then once we add it together, it's 3.25. So once I write my ratio, this over this, it becomes exactly what the last one was. It's the exact same ratio. So then lastly, I want to compare the pink, right? 1, 2, 3, 4. and 1, 2. So new over original, 2 over 4. And 2 over 4 is 1/2. So since the ratio is 1/2 all the way around after we use distance formula, then we know that yes, these are similar. Why? Because we compared the length of all three sides and they all had the scale factor the same. So SSS, similarity. Yes. Okay, on your paper, do not turn this in. If you have a question like this, do not turn this in, because this does not tell me how you got 1/2, 1/2, 2/4, 1/2, or whatever. I need to see all this distance formula stuff, okay? So if you need to turn in a separate sheet of paper, then that's what you need to do, because I got all kinds, this is just from these notes just now, right? I got all kinds of work. That's what your grade is for. Do not forget to show me your work on your paper. I hope that's making sense. It's not really anything new. We're just verifying that after we dilate shapes, that they are, especially specifically triangles, that they are in fact still similar, and they're not always. Okay? Let me know if you have questions.